So we're going to take a minute and talk about something called concavity. Second derivatives have the useful ability to give us information about the concavity of a function. Concavity is just the attribute of some function like this one, and it tells us where the tangent lines are, which also means it tells us where the first derivatives are. And the two types of concavity are concave upward and concave downward, and that's sometimes shortened to concave up or concave down. And usually, like you can see here, segments that are concave will either usually look like a U or like an upside down U or inverted U. Concave up would be this part right here, this U shape. Concave up just means that the function lies above all the tangent lines of the function on that segment. So you can see that the line itself is above these tangent lines. These tangent lines are all below it. And like I said, an interval that's concave up has a U shape. Now this interval right here, kind of from here to here, is concave down. That means a function lies below all of its tangent lines. See the tangent lines here and how the function itself is below those tangent lines. An interval that's concave down looks like an inverted or upside down U. So you can also think of concavity as hills and valleys. Segments that are concave down, like this one, would be a hill. Like if you imagine a person up here, they would be looking down. And you can think of concave up as a valley, so it kind of looks like that, and the person would be looking upward, so it's concave up. So here's where things really get interesting. The sign of the second derivative of the function determines the concavity of the function. So let's say that this thing right here, minus the people, is f of x. It's just some function f of x. This is a segment of it. This is concave up right here. That tells us that from about here, where it changes concavity, to here, where our segment ends, the f double prime of x is positive. So concave up is positive, and from here to here, f double prime of x is negative. So another way to write this is that when the second derivative of f of x, f double prime of x, is greater than 0, f of x is concave up. So when it's positive or greater than 0, it's concave up. And when the second derivative is less than 0, f of x is concave down. So you can think of the U shape as concave up, which has a positive second derivative, and the upside down U is concave down, and it has a negative second derivative. So up is positive, down is negative. A couple last things to go through. So if you do have something that looks like this, the concavity is going to change right there, wherever the line is closest to vertical. Wherever that, see, it's kind of almost vertical there. Wherever that tangent line is about vertical is where the concavity changes. So right here it's negative, right here it's positive. I'm talking about the second derivative, so concave down and concave up. And also, another thing to remember is that you're not always going to get something that looks like this or like this. It's not always going to look exactly like a U. You might get something that has it looks kind of linear, but then kind of curves some. That's going to be still concave down, so a negative second derivative. Even if it doesn't look exactly like a U, if it's close to a U shape, and it's asking about concavity, there probably is an answer there. It's going to be whatever it looks closest to of these.